Have you ever had this experience? You happily bought an electric vehicle with a stated range of 500 kilometers, but then a winter cold wave hits and the temperature drops to 0. You get in the car and see the range slashed in half, leaving only 250 kilometers. At this moment, you must be cursing in your heart. Is the battery broken? Is the car manufacturer lying? Actually, while batteries fear the cold, they aren't the main culprit for the power loss. The real culprit. Here is the thing you find most comfortable right now: the heater. In the era of fuel cars, we never worried that turning on the heater would consume gas. Why? Because engine efficiency is very low. It generates a large amount of waste heat when running. We just took this hot air, which was going to be thrown away, and blow it into the car. This is called waste utilization. But with electric vehicles, the problem is huge. The motor efficiency is too high, so there's basically no wasted heat. So what do you do when it's cold inside the car? Early electric vehicles could only use the dumbest method: burning electricity. Today, we are going to talk about why winter is a physical curse for electric vehicles, and how Tesla uses a part that looks like an alien organ to break this curse. To solve the problem of cold interiors, the earliest electric vehicles, including early Model S and X, used a heater called PTC. The principle is very simple. Just imagine it as a giant hairdryer or the heating coil in a toaster. Electricity passes through, heat is generated. That's it. Although the efficiency of this thing is 100%, meaning 1 unit of electricity produces 1 unit of heat. In the eyes of engineers, this is simply a disaster because every kilowatt hour in the battery is gold. Using it directly to burn into heat is like burning banknotes in a fireplace just to keep warm. It's that extravagant. So later came the savior, the heat pump. What is a heat pump? Simply put, it doesn't create heat. It is just a mover of heat. Its principle is exactly the same as an air conditioner, just reversed. Air conditioning moves the heat from inside the house to the outside. A heat pump moves the heat from outside to the inside. At this point, you might ask, it's -5 degrees outside. And where does the heat come from? This is the magical part of physics. Even in sub-zero air, there is actually still thermal energy contained in it, just thinner. The heat pump works through a compressor, forcibly squeezing out the tiny bit of heat from the outside air and moving it into the car. How high is its efficiency? Usually, the cop can reach 3. That means if you give it 1 unit of electricity, it can help you move 3 units of heat in. This is why all mainstream electric vehicles now install heat pumps, because it directly boosts winter range by 15% to 20%. However, this is not even Tesla's strongest point. Other manufacturers also have heat pumps. So why is Tesla still more power efficient? If you disassemble the heat pump system of an ordinary electric car, what will you see? You will see a nightmare. Countless rubber hoses, dozens of joints, several water pumps, tangled together like spaghetti. The VW ID series and other early EVs are mostly like this. This is not only heavy, but also prone to breaking and slow to assemble. But if you disassemble a Model Y, you will see something strange. A single-piece integrated module, topped with a black cap that looks like an alien totem. This is Tesla's secret weapon, the Octovalve. What is this thing? You can think of it as a thermal energy router. The mindset of traditional automakers is, C handles at C. Battery cooling handles the battery. Motor cooling handles the motor. Everyone does their own thing. But Tesla's mindset is, all the heat in the car, I want to manage it centrally. This Octovalve is like a train switch. It has 8 channels. By rotating, it can instantly switch between a dozen different heat cycle modes. Is the battery too hot? extract the heat and send it to the cabin for warmth. Is the cabin warm enough? Stores the excess heat back into the battery, keeping the battery at its optimal operating temperature. Is the weather outside nice? Then absorb heat from the outside. It integrates the originally scattered systems all into this one brain. That is why Tesla's thermal management system has fewer parts than others. It is lighter than others, yet functions better than others. What gives me the most goosebumps about this system is a function called Lossy Mode. Just now we said heat pumps absorb heat from the air. But what if it's really too cold outside, say -20 degrees, and there's really no heat left to absorb in the air? What then? At this time, traditional heat pumps crashed and can only switch back to that power-hungry PTC heater. But Tesla doesn't have PTC. It removed the heating coil. So what does it do? At this time, the Octovalve will send commands to the motor and battery. Listen carefully. It will intentionally make the motor enter a state of low-efficiency operation. Simply put, it lets the motor idle, or through special current control, causes the coils to intentionally heat up. At the same time, it also makes the battery generate extra waste heat during charging and discharging. This sounds very counterintuitive, right? Engineers spend their whole lives pursuing high efficiency. Yet Tesla intentionally wants low efficiency. But this is where the genius lies. Because at this moment, what we need is heat. Tesla turns the motor into a heater via software control and turns the battery into a hand warmer. Then, through the Octovalve, it collects all this precious waste heat and sends it into the cabin. It's like being in a cold wave with no heater. So you start doing shuttle runs on the spot to generate heat. Tesla doesn't even let go of this tiny bit of energy. Thermal energy bandits. So back to the question at the beginning. Why is Tesla more capable in winter? Because other manufacturers are building cars. When they encounter a problem, they add a part, like adding a heater. But Tesla is deconstructing energy from the heat pump to the Super Manifold, and then to the Octovalve. This whole system proves one thing. The future competition of cars is not about whose leather seats are thicker, but about who can smarter manage every joule of energy. And the scariest part is, because all of this is controlled by software. This means Tesla can even use OTA updates to change an algorithm. And your car's air conditioning will suddenly become more power efficient. This is completely unimaginable in the traditional automotive world. Alright, regarding Tesla's heat pump black technology, that's all for today. Do you think this design of integrating all functions together is a work of genius or a maintenance nightmare where one breaks fixes the whole car? Welcome to leave a comment below and tell me. See you next time. Bye-bye.